Hi everyone, today we're going to learn about differentiation and gradient of the function. Okay, first of all, we will learn about tangent of the curve. Before we start tangent of the curve, let me ask you, for a linear graph, okay, what we know, we can straight away use straight line functions. Y equals to mx plus c, whereby your m can be determined by finding the rise over run, okay, and the gradient are always uniform. How about a curve? How are we going to find their tangents? Let's say we have a curve, something like a quadratic curve. Okay, how do we find the tangent? You will notice that at each point of the curve, okay, they will give you different value of tangents. Okay, they will give you different value of gradient, sorry. So to find out their gradient, okay, what we're going to learn is today is tangent to the curve. Okay, let's look at the notes now. Okay, gradient of the curve at a point can be estimated by drawing a, what we call it is tangent. Okay, at that point and calculating the gradient of the tangents, or we can say that slope of the tangents. Okay, what I mean is we can draw all these tangents, the one I highlighted in yellow. Okay, all these are the tangents to the curve. Okay, we can draw a tangent in order to calculate their gradient values. Okay, so without further ado, we look at exercise 27.1 in your page 2. Okay, page 2 here, right? First of all, okay, I want you to look at the first graph. They say the graph show y equals to x squared over 3 in the diagram. Okay, now they want you to draw by drawing a suitable tangent to estimate the gradient of the curve at x equals to -1 and x equals to 2. Okay, first of all, right, I will make a point here, x equals to 1. Alright, thereafter, I will draw a tangent. Okay, cut across the point. Okay, when I cut across a point, I try to extend my tangent. Okay, now to find out their gradients, what I need to do is I take out 2 points. First point I will take out is -2 and 1. The second point I will take out this point, which is -0.6 and 0. Okay, now first we find out tangent at x equals to -1. So first of all, I will find out the gradient, gradient of the curve as x equals to -1. So when your x equals to -1, okay, what is your gradient? Okay, we can put m equals to y2, that means 1 minus 0, over x2, -2 minus -0.6. Okay, from here we get 1 over -1.4. Okay, to work out this part, okay, I get my gradient is -5/7, or I give my answer is -0.714. Okay, all this is actually an approximate. It doesn't give you any exact, okay, gradient. Okay, the next one, Okay, I need to find the tangent at x equals to 2. Okay, this point. Okay, now we draw out the tangent of the curve. Make sure you draw long enough so that you can determine a nice point. Okay, this one also I will extend a little bit longer. Okay, come to this point and maybe this point. So I will take 0.9 and 0, first point. Okay, the second point I will take 0.8, sorry. This part I will take 2.6 and 2. Okay, let's look at how to work out the gradient of the curve. Okay, when my x equals to 2, what is my gradient of curve? So I will put as y2, which is 2 minus 0 over 2.6 minus 0.8. Okay, from here I get 2 over 2.6 minus 0.8. Okay, I get 1.8 here. Okay, from here, when I work it out, right, I will get my answer 10 over 9. Or I can give my answer as 1.11. Okay, this is one of the example how we find gradient of the curve by drawing a tangent to the curve. Okay, next part, I want you to try out to find out your tangent to the curve for question 3 by yourself, and you can check answer at the back. Okay, now we move on to the next one. Okay, next one we will learn about gradient of a curve. Okay, there is another technique we have to learn today, also called differentiations. Okay, differentiation, purpose of doing differentiation is actually to find out gradient of curves. Okay, so there is a technique of look at it. First of all, we look at the term. How we going to work out the term, how to recognize the term. Now, first of all, to talk about the term, let's say we have an expression called x squared plus 1. So to find their differentiations, what we need to do, we will put d dx bracket and bring in x squared plus 1. This is how you need to represent your work. Okay, second, okay, if the question given y equals to x squared plus 1, okay, if we want to find the dy dx, we have to put dy dx, then with respect to x, then we start to differentiate. Okay, third type of differentiations, okay, probably they will give you function fx equals to x squared plus 1. So to differentiate it, we will put f prime x before we start to differentiate. So how to pronounce this word? We will call as f prime x. Okay, I hope you guys write down all these terms, how we're going to do the differentiation before we start to do differentiation. Okay, generally, what is the formula of learning differentiations? Okay, first of all, for example, I give you y equals to x to power n. Okay, when we want to differentiate, we will put dy dx. Okay, what we're going to do, we will drop down our power of x in front, so we become n x to the power m minus 1. Okay, what about number 2? If we have y equals to 2, okay, it's a constant. So when we differentiate, it will become 0. Okay. Third one, the third rule. What about if I give you y equals to a function fx? So when we do differentiation dy dx, okay, first we have to do put to the power of n. So what we're going to do is we will drop down the power in front. So to differentiate, we drop down power n. Okay, write back fx to the power of n minus 1. Thereafter, we have to differentiate the expression inside our fx again. Alright, let's look at some example in exercise 27.2. Okay. Okay, I'm going to move up these rules so you can refer. Okay, maybe we look at question D. Okay, in question D, they said find the derivative of each functions. So look at that. They give the term fx. So what we need to do, when we differentiate, we put f prime x. So first of all, I have x to the power of 5 over 5. So what we do is, I take out 1 over 5 first. Okay, drop down my power 5. Okay, write back my x and reduce my power of x to 4. Okay, if you cannot get it, maybe you can write 5 minus 1. Okay, plus the next thing, also the same, we drop down the power of 3. Okay, write back x and reduce the power 3 to 1. And constant, right, is also remain constant. Constant we cannot differentiate because my function only differentiate with respect to x. So after that, we simplify. Okay, first part, my 5 can be cancelled off. So I only leave x to the power of 4 and plus 3x to the power of 2. Okay, this is how we do differentiation. Okay? Okay, next part of the term, I want you to look at how to find equation of the tangent. Okay, let's look at the next one. Okay, they say the fx function have x squared minus 4x plus 3. Okay, we're looking at question 5. So first of all, they ask you to find the derivative of fx. So part 1. So my fx function, I rewrite my exact function is x squared minus 4x plus 3. Okay, to work out the derivative f prime x, same thing, I drop down my power x is 2x to the power of 2 minus 1. Okay, minus 4 times my x after differentiate, it become 1. It have nothings. Okay, so my function will become 2x minus 4. Part 1 done. Okay, part 2, B. Okay, in B, right, they are asking you what is the rate of y with respect to x when your x equals to 1. So come to this question, basically what they mean is they will ask you to find the rate of change with respect to x, meaning they are asking you about the value of the rate of change is the differentiation value, the derivative value of fx. Okay, so come to this part, right, what we need to do, I put back f prime. Okay, my x have to replace with 1. Okay, big Y, because we are finding the value of the gradient. Okay, so come to this part, right, we will substitute 2 times 1 minus 4. So my gradient of the value will be negative 2. Okay, that is part B. Okay, part C. Part C is the most important one that I want to tell you. Okay, part C, they said write down the equation of tangent. What does mean by equation of tangent? What they mean in this question is, okay, this is your quadratic curve. Okay, probably you put a point at x equals to 1. Okay, and you will draw a tangent to the curve. Okay, this line we call as the equation of tangents. Okay, how do we find the equation of tangent? Okay, equation of tangent, right, generally is a straight line curve. Y equals to mx plus c, whereby this time now your m, right, no longer using the straight line equation formula. Instead, the m is actually represent your value of your dy dx, or we call f prime x. Right, to work out this question, first of all, we know that part C, we have our gradient value, which is f prime x from part 2, part B, which is negative 2. Okay, this is not enough, because from here, right, we need to form an equation. The next thing what we need to do, we need a point, okay, to work out the entire equation. So come to this question, as what we know, they are asking you equation tangent of x equals to 1. So I need to take this point x equals to 1, okay, sub into my original equation fx1, okay, to find out what is my y value. So I will put 1 square minus 4 times 1 plus 3. So my y coordinate is actually equals to 0. Okay, once I got all the information, what is the next thing is I can form an equation of equation of tangent, sorry. So the next part, what we need to do, we substitute, okay, f prime x equals to negative 2, and the point 1 and 0 into y equals to mx plus c. So from here, right, what we got here is y equals to 0 and my x is 1 multiplied with my gradient negative 2 plus c. So basically my c is equals to 2. Okay, so therefore my equation of tangent is y equals to, okay, find out my gradient value, which is negative 2, put it negative 2x. Okay, after that, what is my interception? C equals to 2 plus 2. Okay, this is how we find out equation of tangent. Okay, before we continue the next part, okay, I want to do a summary, okay, for equations of tangent. There are a few steps you need to remember. Okay, step number 1. Okay, first of all, what you need to do, you need to find out the gradient, okay, which is dy dx or f prime x. Okay, and its value. Okay, number 2, what we're going to do, Okay, we also need to find out the coordinates of the points where the tangent exists. Okay, step number 3. Once we got these two answers, okay, we have to substitute. Okay, substitute our gradient, the gradient of a curve and the point. Point in step 2 into y equals to mx plus c. Okay, not yet done. Okay, this only help you to find your c, your y-intercept. Don't forget, we have to form the question nicely. The last part, form the equation of tangent in y equals to mx plus c. Okay, probably I should write it as form the equation of tangent in the form. In the form of y equals to mx plus c. Okay, thank you.